All right, y'all, we got to use this version of the slides this time because the ones that they gave me in the other version are completely wrong and they don't match your pages at all. So I don't know what that's about, but we're going to use these because they do match. So this is lesson 5-2, which is numerical expressions and how to evaluate them. So we're going to talk about things like order of operations, which you've maybe heard of. So let's get started. A numerical expression is a combination of numbers and at least one operation, such as 4 squared plus 7 divided by 3 minus 1. So an operation meaning like addition, division, subtraction, multiplication, something like that. So as long as it has one of those, then it can be considered a numerical expression. To evaluate a numerical expression, you find its value. So you solve it, basically. It can be evaluated using the order of operations. The order of operations are the rules that tell which operation to perform when more than one operation is used. This guarantees that the same value of a numerical expression is found each time the expression is evaluated. So in other words, you follow the order of operations to make sure that you get the right answer, because sometimes they write these things in just random orders and it's important to solve them in the correct order. So here are the steps of the order of operations. We've got number one, simplify the expression inside of grouping symbols such as parentheses. So some of us maybe know this term PEMDAS or GEMDAS. That's actually what this is. So I'm going to very poorly write some letters here. We've got a G here for grouping symbols. Some people use a P for parentheses, but there are other grouping symbols such as brackets. So this way you know with the G that it's going to be all symbols that group things together. So we've got G for grouping symbols. Step two, find the value of all powers. So remember, this is a power, and that what we call that is E for exponents. Here, actually, I'll write it over here. Sorry, I'm really bad at this. E, isn't it cute? Okay, then we've got multiplying and dividing in order from left to right. And so that's gonna, I'm gonna literally run out of space. M D, oh, that's bad. Can I undo that? No, I can't. That's wrong. Took away my stuff. Oh, I'm sad. All right, well, anyway, I'll rewrite it in a second. Multiplying and dividing in order from left to right. That is important because, like, if the division shows up first, like on the left, do it first. Just because they wrote multiply and divide in this order doesn't mean you have to multiply first and divide second. Anything, however it comes up from left to right. And then fourth, the same thing with addition and subtraction, left to right. If it's add and then subtract left to right, then you add first, subtract second. If the subtraction comes up first, do that. So just go from left to right. And so here, let me write this better. That's my ugly G. There's an E for exponents. And uh, you all deserve this, honestly. It's Friday. Okay. GEMDAS. That's how you can remember it. That's meant to be grouping symbols, exponents, multiplying and dividing, addition, and subtraction. Let's watch this video down here to hello. I'm struggling. Oh, okay. I'm struggling. All right, here we go. Let's watch this video. They're going to show you how to solve one.
Evaluate the expression 6 squared minus 12 divided by 3 plus the quantity 14 minus 9 times 2. Use the order of operations to determine which operation to perform first. First, look for any grouping symbols, such as parentheses. Simplify the expression inside the parentheses. 14 minus 9 is 5. Next, find the value of all powers. 6 squared is 36. Then multiply and divide in order from left to right. Start with the leftmost operation first, division. 12 divided by 3 is 4. Then multiply. 5 times 2 is 10. Finally, add and subtract in order from left to right. Start with the leftmost operation first, subtraction. 36 minus 4 is 32. Then add. 32 plus 10 is 42. The expression simplifies to a value of 42.
Thanks, robot guy. All right, so here we go. No, just skipping that. Okay, example 1, evaluate numerical expressions. So we've got a thing here to evaluate, 100 minus 3 squared times 6 plus 4 in parentheses plus 2. So first, we should write out the expression, and then we are going to simplify inside of the parentheses because of the grouping symbols comes first. So 6 plus 4 is 10. So we've made a 10 over here. Then we can evaluate the exponent. 3 squared is 9. So we can replace 3 squared with 9. Then we are multiplying because there is no division. So multiplying comes first. So 9 times 10 is 90. And then we are subtracting first because that comes first on the left. So 100 minus 90 is 10. And that leaves us with just a plus 2 here, which equals 12. Okay, so the value of the expression is 12. Yeah, cool, we get it. Thanks. Why was subtraction performed before addition when the expression showed 100 minus 90 plus 2? Because it's from left to right, not addition, subtraction in that order. It's from left to right. Common mistake there. All right, you guys try out your check. As you probably know, this isn't going to load anything important, but you have it on your page. Try it out and see how it goes. We're going to move on to example 2, evaluate numerical expressions again. So this time we've got, it's a little more complex here. We've got 5 plus, and then parentheses, 8 squared divided by 2/5, and then times 2. So we wrote it out. And then inside the parentheses always comes first, but since we actually have some other stuff inside the parentheses, we have to follow the order of operation kind of like inside here as well. So inside here, we've got an exponent, so we want to do that first. So that's what they have done here with our 64. 8 times 8 or 8 squared is 64. And then they can divide 64 divided by 2/5, which gives us 160. Okay. Then we've got a multiplication thing. Even though it's at the end, it's still multiplying before adding. So we've got 160 times 2. They want us to type this here for real. Okay, that's going to be 320. And then we are going to finally add 5 plus 320 to bring us to the final answer. All right. Okay, we already know it's 325. Now it's your turn again. Try it out for yourself. All right, we've got one other thing to look at here. That was evaluating numerical expressions. Now we're going to look at how to write them in order to solve like maybe a more complex word problem here. So in a real world situation where one or more operations occur, you can write an expression to represent the situation. So we're going to go ahead and try that out. We've got Mariana and her friends are buying snacks at a hockey game. Hot dogs cost $4, boxes of popcorn cost $2, and drinks cost $2.50. Write an expression to represent the total cost of 4 hot dogs, 3 boxes of popcorn, and 2 drinks. Okay, so 4 hot dogs, 3 popcorns, 2 drinks, and these how much they cost. So we are looking at hot dogs first. Hot dogs are $4 and we're getting 4 hot dogs. So we can complete this expression here. So we have $4 times 4 hot dogs. Okay, that's from the problem. And then we've got $2 boxes of popcorn and we want 3 of them. So we can put 3 here. Notice we're going parentheses here, 4 times 4, and then we have a plus, and then another parentheses. We've got 2 times 3. And then finally, our drinks are $2.50. So we have another plus and then parentheses, and we're buying 2 of those. So we have our expression there. 4 times 4 in parentheses plus 2 times 3 in parentheses plus 250 times 2 in parentheses. All right. And then you could solve that if you wanted to know how many or how much money it was going to cost or something like that. Skip that, talk about it. And let's do one last example here. We're going to write a numerical expression about Paula, who is shopping for the items shown in the table. We're going to represent an expression, write an expression to represent the total cost of 5 lotions, which cost $5 each, 2 candles, which cost $7.80 each, and 4 lip balms, which cost $2.48 each. So we are going to see how to do that. Part A, write the expression. So we're going to write this out. We want it to be, since we want to know how much stuff costs, we're going to be adding each cost together. We're going to add the cost of lotions plus the cost of candles plus the cost of lip balms based on how many of each she's buying and how much they cost individually. So the cost of lotions here we could write as 5 squared. The cost of candles we could write as 2 times $7.80, and the cost of the lip balms we could write as 4 times $2.49. So that is because she's buying 5 lotions for $5 each, so 5 times 5 is 5 squared. She's buying 2 candles and 4 lip balms. Okay. So then, once you've written it, they usually want you also to solve it. So let's go ahead and try that out. So we've got 5 squared plus 2 times 7.8 plus 4 times 2.49. Steps are parentheses first, the grouping symbols first, but we have 3 grouping symbols. So what we just will go through them left to right just for simplicity's sake. So they have 25 here because 5 squared, and then we could do 2 times 780, and we'll fill that in a second, and then 4 times 2.49, which is $9.96. So they want us to do this one, 2 times 7.8, which is, why isn't it typing? Oh, I didn't click in the box. Sorry. That would be 15 point. It's money, so we could put 15.60. Let's put that and see if that's what they like. Yeah, okay. Technically, you could leave that 0 off. All right. Okay, so we did our grouping symbols. So we did that. That is enough, because then we can just add these totals together. There's only one type of operation here, which is addition. So we don't have to go through and do multiplying and dividing. We're just adding them together, and that gives us 50.56 or $50.56. Okay. So there's that. We're going to skip that. And then the last thing you need to do is the check, which looks cooler than this. So try it out, read it carefully, and then yes, do evaluate it as well. That's it for this lesson.